So there's another topic that I'd like you to be thinking about. This isn't something that's covered in most calculus courses, but it's really important if you want to go into engineering or physics, particularly, or just into any field that uses approximations to numbers, because mathematics, if you do mathematics with computers, if you do mathematics with real world numbers, you're going to be doing lots of approximations. And so this is something that we'll be developing the tools to handle as part of this class. And I want to give you kind of a preview of what some of those tools might look like. So here I have sketched out, and this actually isn't a very good sketch, of the graph of y is equal to x squared. It turns out that the graph of y is equal to x squared is a little bit more like a straight line than I've drawn it, around x is equal to pi, right? So here we're really interested in this question of, what is pi squared? How could we calculate that? And hopefully you've already taken the time to think about that problem already, as to how we could calculate pi squared. And I encourage you to, if you haven't thought about that question yet, pause the video and think about the question. How would you figure out what pi squared is? How would you figure out its decimal digits? Things like that. So what we see here, we have our graph. And of course, the thing that we're interested in is if we go to x is equal to pi, and we draw a vertical line until it hits the graph, and then that y value that we get there, whatever this y value is, where this vertical line hits the graph, that y value is going to be pi squared. And actually, if you're clever, you'll notice that this is not drawn to scale. Pi is actually much closer to 3.14 than it is to 3.15. But don't worry about that. So what we can do to figure out what some range that pi squared is in is, right, we have here our 3.14, and we can put that into our function and figure out this y value here. And this y value here is going to be 3.14 squared, which, now, this is an important thing. You can put any of these things into your calculator, right? You can put pi squared into your calculator. You can put 3.14 squared into your calculator. And they'll both tell you an answer. But here's the thing. You could also calculate 3.14 squared by hand, right? You know all of the steps that it takes to figure out what 3.14 squared is, right? It's going to be awful, right? We have to do 3.14 times 3.14. It's going to look like this. There's going to be some numbers here. They're not zeros. I'm just, showing you what the thing will look like. There'll be some more numbers here. Maybe we have some extra digits here, and we add up all of our digits, and yeah, this thing that you've learned how to do. We want to multiply numbers together, and you know all of the steps of that process, right? You could get an answer. You could do all of this by hand. And it's important to remember that a lot of calculus came around not just prior to the age of pocket calculators, but actually because we were living in the age prior to pocket calculators. A lot of these tools were invented to make the process of doing computations either possible or easier. In terms of, if somebody wanted to figure out the digits of pi squared, they couldn't just type it into their calculator. But if they wanted to figure out the digits of 3.14 squared, again, you can just do that. We've known how to do that for centuries. And then, of course, if we plug in 3.15 squared, we're going to get, it's going to intersect the graph way up here, right? We just go to x is equal to 3.15, and we go up until we hit the graph. And then when we hit the graph, that's going to be 3.15 squared. Now, I'm lazy, so I have already gone ahead and plugged these into a calculator. But again, appreciate that you could do this without a calculator. You could do all of this, you could calculate 3.15 squared by hand, and that is 9.9225. And this 3.14 squared is 9.8596. And these are exact. This isn't, these decimals don't go on forever. These decimals are exact for these things. And what that tells us is that pi squared is somewhere between 9.8596 and 9.9225. And again, that's something that we figured out because the graph is nice, right? If the graph was horribly broken up into lots of different pieces that went all over the place, this wouldn't work out that nicely, right? We wouldn't know that pi squared is somewhere in between these two values. But we know that pi squared is somewhere between 9.8596, and it's actually going to be somewhere strictly between, and 9.9225. Now, what does that actually tell us about pi squared? What does that tell us about the decimal digits? Not much. It tells us that if it's going to be a number between 9.8 something and 9.9 something, then the number has to start with 9.8 something if it's between here and 9.9, or it's going to be 9.9 something if it's between 9.9 and 9.9225. So we actually don't know if pi squared right now, if pi squared is 9.8 something or 9.9 something. And of course the rest of the digits, we don't know anything about the rest of those digits. But again, keep in mind that, think about what's going on in the minds of mathematicians and physicists and engineers, people who, maybe we need to calculate what pi squared is. Think about what people would be thinking about prior to the age of calculators, where you could just plug pi squared into the calculator. Well, what are they thinking? Well, they're thinking, I'm going to need to go back and do this all over again, right? I'm going to need to, first of all, hope that I remember the digits of pi. And then I'm going to need to go ahead and do this process all over again, right? I'm going to need to say, well, instead of saying that pi is between 3.14 and 3.15 and using that to figure out some upper and lower bounds on pi squared, I'm going to have to go back and try again, but this time with 3.141 and 3.142. Right, I know that pi starts off, the decimal digits of pi start off 3.14159, and so on and so forth. So I know that pi starts off with 3.141, and that means that pi is somewhere in between 3.141 and 3.142. And okay, now we have to go ahead and calculate what 3.141 is, and what 3.141 squared is, and what 3.142 squared is. And that gives us some upper and lower bounds on pi squared. And if you're a mathematician back in the day, you say, hold on, maybe I should just do a little bit more work here and save myself some headache later on. What if I said, oh, well, it's somewhere between 3.1415 and 3.1416, right? I know that pi is between those two numbers. Give me a better estimate on pi squared. It's going to be a little bit more work because I have to square larger numbers, but it means that if I'm not happy with the result that I got, right? When we used 3.14 and 3.15, I wasn't really happy with the result here, right? All that we discovered was that pi squared either starts off with the digits 9.8 or 9.9, and that really isn't an exciting result, right? So, well, we know that pi squared, we definitely know it's one's digit, and we have its 10th digit narrowed down to two possibilities, and that isn't really exciting. That isn't something that you can go out and share with your mathematician friends. Oh, I calculated the digits of pi squared, and they say, well, how many digits of pi squared did you calculate? And you say, well, I know the first one. That's not really exciting. And so maybe you get really excited and you say, well, okay, let's add a bunch more digits. Let's say we know that pi is between 3.14159 and 3.14160, right? I know that pi is between those two numbers. And now you sit there and you have to say, well, I have to square these numbers now. And again, think about this as like in the age prior to the pocket calculator. Oh, this is kind of intimidating to have to square by hand. Oh my goodness. And you say, well, is this going to be worth it, right? How many digits am I going to get? What sort of range of values am I going to wind up getting? And really what the question you're asking is, so I haven't redrawn this graph, but really what's happening is every time we add more digits to this range, what we're really doing is we're picking values of x that are above and below pi. They get closer and closer and closer to the actual value of pi. And what that means is that when the values of x get closer to pi, the values of y are going to get closer and closer and closer to pi squared. Right? That's what seems to be happening here. As we narrow down the x values, the y values seem to be narrowing down on pi squared. But one of the important things to keep in mind here, and this is probably the thing that's going through this pre-pocket calculator mathematician's head, is how big is this range going to be, right? Because if it's really big, we're not going to get a lot of information about where pi squared actually falls on the number line. And if it's small, well, that's really good. We're going to get lots of information about where pi squared falls on the number line. And so one of the questions that you might want to ask is, if we have a range of values and we input that into our function, we're going to get some range of values as output, right? We know that pi is somewhere between here and here. We know that pi squared is somewhere between here and here. And the question that you might ask is, if we have this range of values, how big is this range of values going to be, right? When we were doing this with 3.14 and 3.15, the range of x values was, well, let's go back to that case here. Go back to 3.14 and 3.15. This distance here is 0.01. It's 1/100th, right? And this distance here wound up being, well, this y value is 9.9225, and this value here is 9.8596. That's the thing that we calculated from before. And the difference there is going to be, let's do this calculation, let's see, well, let's just subtract those. This distance here is 0.0629. Right, so I've actually drawn the slope of this thing terribly because this distance here is actually 6 times as big as this distance here if I had drawn this graph to scale, right? This is, it's more than 6 times as big. It's 6.29 times as big. It's almost 6.3 times as big. This distance here is much bigger than this range here, and we kind of saw that in the sketch here, but it's 6 times as big, and that's why we didn't get as much information as we might like out of squaring pi when we just use these lesser approximations. And so, again, this is a thing that you want to be thinking about if you are a physicist or an engineer, is in terms of approximations, because we use approximations every day, right? When you make a measurement, there's approximations to it. And I'll talk some more about that in another video.